Hello guys, welcome back to our YouTube channel Maths and Electronics Tutorials. Today in our video we are going to learn about the derivation of velocity modulation signal. Please watch the video of two cavity klystron before this so that you can understand this much better. For the derivation of velocity modulation, we have to find the term Vt1. Vt1 is the output of the buncher cavity and T1 is the time where the bunches are formed. Here Vt1 is represented as Vo plus Vs. Here the Vo is represented as the velocity of electron and Vs is the average voltage. Vo is represented as under root 2e V0 m. Here this V0 is the cathode voltage, m is the mass of electron, e is the charge of electron. Here we have to remember that V1 is always very less than V0. V0 is the cathode voltage and V1 is the peak of the RF signal, that is the amplitude. Now we also know that potential energy is converted into the kinetic energy. So EV0 is converted into half mV0 square. Now the average transit time of a buncher cavity is given as tau. Now this tau can be represented as T1 minus T0. T1 is the time at which the electron leaves the buncher cavity and T0 is the time at which the electron enters the buncher cavity. The average transit angle of the buncher cavity can be represented as theta g, and theta g is represented as omega naught tau, where here we have seen that tau is T1 minus T0. So we have to substitute T1 minus T0 in the place of tau. Therefore theta g, which is the average transit angle, will become omega naught of T1 minus T0, which is omega T1 minus omega naught T0. The next step would be to find the average voltage of the buncher cavity gap from T0 to T1, and this average voltage is denoted with Vs. Vs can be represented as 1 upon T1 minus T0 integration of T0 to T1 and V1 sin omega t dt. Here we have to perform the integration. So after performing the integration, we would get Vs is equal to minus V1 upon omega tau of cos omega t of T0 to T1. Now we have to put these limits. After substituting the limits, it would be minus V1 upon omega tau into cos omega T0 minus cos omega T1. We know that T1 is equal to T0 plus tau, as tau is equal to T1 minus T0. So we have to substitute this equation in the above. After substituting, we will get minus V1 upon omega tau of cos omega T0 minus cos omega T0 plus omega T. Here in this equation we can see that this formula can be applied, that is cos A minus cos B is equal to minus 2 sin A minus B by 2 sin A plus B by 2. So we would consider this as A and this as B, and this is cos A minus cos B. After applying this formula to this equation, we would get it as Vs is equal to 2 V1 upon omega tau sin omega tau by 2 sin omega T0 plus omega tau by 2. After solving this, we would get it as Vs is equal to V1 upon omega tau by 2 into sin omega tau by 2 sin omega T0 plus omega tau by 2. Now we also know that omega tau is equal to theta g. So we have here in this equation we can see that omega tau is present. Also we know that theta g is equal to omega tau. Hence we can substitute this theta g is equal to omega tau in this equation. After substituting the theta g, we would get the equation as Vs is equal to V1 upon theta g by 2 sin theta g by 2 sin omega T0 plus theta g by 2. So we can take here Vs is equal to V1 sin theta g by 2 upon theta g by 2 sin omega T0 plus theta g by 2. Now here in this equation we would consider sin theta g by 2 upon theta g by 2 as beta I, which is beam coupling coefficient. Therefore, the equation for the average voltage would be Vs is equal to V1 beta I sine omega t naught plus theta g by 2. This is the final equation for the average voltage. So now we know that average voltage, which is Vs, is V1 beta I sine omega t naught plus theta g by 2. And we also know that to find the velocity modulation equation, we have to add V0 plus Vs. Here V0 we already know, which is 2e V0 upon m. Here this V0 represents the cathode voltage and this V0 represents the velocity of electron. Now we have to substitute the values of V0 and Vs in this equation. Now we know that Vt1, which is the output of buncher cavity, is equal to V0 plus Vs. V0 is equal to 2e V0 upon m under root. So we know that V0 value is this, and we also got the value of Vs as V1 beta I sine omega t naught plus theta g by 2. So now we have to substitute this value of V0 and Vs in this equation. After substituting the equation, we would get Vt1 as under root 2e V0 upon m plus V1 beta I sine omega naught plus theta g by 2. Now we have to take Vo as common here. After taking Vo as common, we would get the equation as under root 2e V0 upon m into 1 plus beta I V1 upon V0 sine omega naught plus theta g by 2. Now the final equation of the velocity modulation in terms of TO for the buncher cavity will be V1 of t is equal to V0 of 1 plus V1 beta I upon V0 sine omega t naught plus theta g by 2 whole square. I hope that you understood the final equation of the buncher cavity. Thank you for watching the video. Please like, share and subscribe to our channel. See you in the next video about the Applegate diagram of the two cavity klystron. Thank you.